Good morning, students. Myself, Narottam Mondol, the faculty of George Telegraph Training Institute in Baharampur branch. Today, I want to show you the basic concept of electricity. As I was discussed in my previous class, that I just showing you. As I discussed in my previous class, electrostatics, Coulomb's law, capacitance. Up to capacitance, I was discussed in my previous class. So now I will try to discuss you once again because so many days already gone and you also forget that topic. That's why I told or start from the beginning. So first point is electrostatic. So what is electrostatic? What is electrostatic? Actually, I was told you that electricity basically, or electric current is basically two type. One is static electricity and another one is dynamic. So in this session I will discuss you about the static electricity. Electrostatic is nothing but a static electricity. Actually, if you asked me that what is electrostatic, actually electrostatic is it is a branch of physics where we're discussing about the electric charge in the rest condition. Okay, so electrostatic, it is the branch of physics where discussing about the electric charges. Electric charges at a rest condition. I will told you, or I will show you in the note I will given you in PDF format. So don't worry about this. So first thing is that what is electricity? Static electricity. Static electricity is electrostatic, and electrostatics and static electricity are the same thing. Electrostatic, what is electrostatic? It is a branch of physics where discussing about the electric charges at a rest condition. Basically, there is the charges in this electricity. The carrier is the charges. So here charges are not moving. They are in this section, or in this uh, branch of electricity, the charges are not traveling one point to another point. Okay, so that's why it's called static electricity. In dynamic electricity, the charges are flowing to one point to another point. So that is why uh, you can say that these are dynamic electricity. So that is the two biggest difference between static electricity and dynamic electricity. So static electricity is the part of the static electricity, or the laws. uh, okay, the materials, I forget to mention that the materials of electrostatics. So basically, uh, electrostatic materials are static materials: rubber, plastic, wood, amber, etc. Lots of things in our daily life we are use that type of material, are the materials. You can call those materials as a electrostatic material. So basically it has some periodic structure, okay, according to the charging capacity of that material. So basically, rubber, plastic, wood, amber, those materials have some positioning of periodic table, in the periodic table. Okay, so these are the electrostatic material. Now we will discuss the Coulomb's law. Next point is Coulomb's law. Okay, so what is Coulomb's law? Coulomb's law is the law of it is a law of scientist Coulomb, given to us according to the according to the electrostatics charge particle. He analyzed that two point he analyzed that if 2 point having the charge of q1 and q2, between them, if you consider the distance between them is r, then Coulomb's law state that in between them a force a force will a force, either it is repulsing or attracting force, acting between them. Why? These two charges if these two charges are positive, then it will repulsing. And if these two charges are opposite to each other, that means if it this charge is plus q1 and this charge is minus q1, then it will attracting between each other. So Coulomb's law state that the force, attracting force or repulsing force, first statement of Coulomb's law is that first the force between 2 points for charges F is proportional to, F means here, F means force is proportional to Q1 and Q2, where R is constant. R is constant. Here R is the distance between A and B. Okay. Here R is the distance between A and B point. So if you forget that, I mentioned that symbol R. What is the symbol R? So next statement, Coulomb state that R is proportional to R is inversely proportional to distance between 2 points. R is squared inversely proportional to between distance between 2 points. So in this way, I just written here F is inversely proportional to squared inversely proportional to distance between 2 points, where Q1 and Q2 are constant. If you conclude these two equations, we get F is proportional to Q1 and Q2 divided by R square. So F is equals to K into Q1 into Q2, or here K is nothing but 1 by 4 pi epsilon 0. K is nothing but 1 by 4 pi epsilon 0. So instead of K, I will put here 4 pi epsilon 0. So Q1 Q2 R square. This is the final equation. So in your mind, a question arises that what is epsilon? Epsilon 0 is the permittivity of the air. It is the permittivity of air. Okay. So this is the equation of Coulomb's law. Actually, if you state that what is Coulomb's law, then Coulomb's law state that the force acting between two charge point is proportional to product of the two charge particle, and it is inversely proportional to the distance between two charge particle, the square and inverse square proportional to between two charges. So here we showing you that F is first point is F is proportional to Q1 and Q2, and second thing is F is proportional to 1 by R square. So after concluding these two equation, you can write here F is proportional to Q1 by Q2 by R square. F is equals to, if you change it proportional, if you change the proportional into equals to, then a constant will multiplying by this portion. So that's why K is a constant multiplied by this portion. So K is a constant which value is 4 pi epsilon 0, and here epsilon 0 is the permittivity of the air. It has some constant value. I will show you later. So next, F is 1 by 4 pi epsilon 0 into Q1. Hello. Okay, now here is the Coulomb's formula, is the final formula of Coulomb is F equals to 1 by 4 pi epsilon 0 q1 into q2 by r square. Here epsilon 0 is permittivity of the air and its value is 10 to the power 9 divided by 36 pi is equals to 8.854 Coulomb square Newton inverse meter square inverse square, sorry. Here 1 by 4 pi epsilon 0, as I told you, force is equals to 1 by 4 pi epsilon 0. Here it is the constant value. So the value of 1 by 4 pi epsilon 0 is equals to 8.987 into 10 to the power 9 Newton meter square Coulomb square, or it near equals to 9 into 10 to the power 9 Newton meter square Coulomb inverse square. So for your kind information, these two constant value you can remember for problem solving at the time of problem solving. So now the next point, number 3 is capacitance. These are the point of your syllabus. I just discussing you that these are points according to your syllabus. So third point is capacitance. Here capacitance, what is capacitance? Capacitance is a property of a condenser. So here it is the property of a condenser to store or deposit charge or electric charge, you can say, electric energy or charge between two plates which is separated by the dielectric medium. So if it is a condenser, or sorry, capacitor or capacitor you can say. So capacitor, the internal structure of a capacitor is like that. The two plates, these are the two conductive plates. So here is the dielectric medium. So this dielectric medium is either air or some material like what I am say, like plastic or some other materials you can use as a dielectric medium. So these two plates are conductive, like ferric or copper, whatever you can take these two conductive materials, you can use this. So here when you supply these two plates using DC volt, then this plate in this region, positive plate here, it create negative charge, and this negative plate, this edge side is making negative, sorry, positive charge. So in the positive plate, this in the this edge the charge is negative, and in this plate, this edge, the charge is positive. Actually this charge, storing charge, these are the storing charge. So whenever the DC voltage remove, this charges remains here. So this is the system of capacitance. So it denoted by F. SI unit is farad, or the symbol is F, or sometimes its value, sometimes we see that this capacitance value expressed by microfarad, millifarad. These are the smallest unit of capacitance. So this is the, sorry, denoted by, here is the symbol, it is denoted by C, not F, I'm sorry. So this is the symbol of capacitance. Whenever you see in the circuit diagram, on that portion C mentioned there, and this C is nothing but a capacitor sign. So the symbol is, this is the symbol, this is the symbol of capacitance. Okay, so this is the all of capacitance. And if you see the combinations, we will discuss the combination of capacitance, resistance, and other passive elements later. So these are all the things of capacitance. Now we will discuss about the charge and the current relationship. So basically in your syllabus, the relation between charge and current. The relation between charge and current is, actually we know that Q equals to CV. Here Q is the expression or the relation between Q, for it is here Q is nothing but charge, C for capacitance, and V for voltage. So it is charge, C is capacitance, B for volt. So now charge and current relationship. So current relationship and charge, actually we know that current is nothing but the ratio of Q and T. Current is the ratio of Q and T. Here Q is the charge and T is the time. So it is the rate of change of charge. Current, what is current? Current is the rate of change of time. So this is the expression or relation between charge and current. Okay, so here SI unit, sorry, charge SI unit is coulomb, or symbolic expression C. CGS unit is ESU, electrostatic unit. So this is the unit of SI and CGS of charge, and capacitance, as I already discussed it, and time, you know that time SI and CGS unit are same. So now current is the rate of change of time. So this is the relation between charge and current. Whenever in your exam question paper asked, whenever whenever some question, if some question arises in your examination question paper, that state that the charge and current relationship expression, then you just put it I equals to Q over T. I'm not explaining how it write, because in your syllabus there is no explanation, and so that is why I just put you here, just a relationship between charge and current. Okay. Third point, Ohm's law and resistance. So now first I will discuss the resistance. What is resistance? Resistance is the property of a material where it opposes the flow of current. So resistance is the property, it is the T of a where it opposes the flow of current in a closed loop. Or in a circuit. in a closed loop or circuit. So this symbol is R. Whenever you see in the circuit diagram that R symbol, it is nothing but the symbol of resistance. Okay, so SI unit of resistance is equals to ohm, or this symbol you can use instead of ohm. So SI unit is ohm and symbol in the circuit diagram here R, and symbolic representation R, or in circuit diagram this symbol you can see in the circuit diagram of electricity or electric circuit diagram. So this is the diagram of resistance. Okay, don't worry, I just take those pictures as I mentioning here or as I discuss. Sometime when you see the total conversation by the YouTube or some other apps, or like WhatsApp, on the time you do not see the actual picture, don't worry, I just take those picture, whatever I am discussing here, I put it in the description box as a PDF format. So don't worry, I will give it to you in the PDF format in the comment section. So don't worry. So this is resistance, and now I will discuss Ohm's law. So what is Ohm's law? Actually, scientist Ohm's is the invention of resistance. Okay, actually resistance invented by the scientist Ohm. So what is his law? His law states that if it is a closed loop circuit, this is battery EG, and A point, it is the B point. The voltage of A point is VA respect to ground, and B point voltage is VB respect to ground. So if I assume that the current flowing through these closed loop, here is the current is I and flowing through A to B point. So Ohm's law state that the current flowing through a conductor, it state that the current flowing through the conductor is when current flowing through the conductor, it said that when the current flowing through the conductor is directly proportional to the voltage difference between two points. Okay, and mentioning that when it state that actually and keeping mind that keeping the physical condition unchanged. So this is the Ohm's law, and here the explanation, if you see the circuit explanation, if I is equal to current flowing through the point A to B, so from the Ohm's law you can state that you can say that current is proportional to VA minus VV, where I already say that VA, what is VA? VA is nothing but voltage at point A, and V is the voltage at point B. So this is B and A. Sorry, V and VA and VV. So if you say that VA minus VV is equals to V, if you let or say, then I is equals to V, or you can write opposite direction, V is proportional to I, or V is equals to K into I. Here K is the proportional constant, K is constant. Okay, so V equals to Ri. So here R is resistance. So this is the final equation of Ohm's law. So here V is the voltage difference between A and B point. R is the resistance of the conductor. I is the current. So it is in volt and it is in ohm. Our current is in amp or ampere. Okay, so this is Ohm's law. So this is all for this day. Next I will discuss the types of resistance and other things also. I will cover all the portion of your syllabus by this way. So thank you.